Concentrated solar power, or CSP, concentrates sunlight with mirrors to make high-temperature heat. That heat drives steam turbines, just like a conventional thermal plant, but the sun is the fuel. Because CSP is a thermal technology, it pairs naturally with inexpensive heat storage, usually molten salt. Plants can deliver electricity long after sunset and provide grid services like ramping and inertia. Here is the core idea: a solar field of mirrors redirects sunlight to a receiver. A working fluid gets very hot, then either makes steam immediately or stores that heat in insulated tanks for later use. CSP comes in for main designs, power towers, parabolic troughs, linear Fresnel systems, and dish Stirling engines. Each focuses sunlight differently but aims for the same outcome: hot, useful heat. Power towers use thousands of heliostats to reflect light onto a central tower receiver. They reach the highest temperatures and are common in newer projects because higher heat boosts efficiency. Parabolic troughs use long curved mirrors to focus light onto a tube carrying a heat transfer fluid. They are mature and widely deployed, offering proven performance and straightforward operations. Linear Fresnel systems approximate a trough with flatter, cheaper mirrors, trading peak efficiency for lower cost. Dish Stirling units concentrate sunlight onto an engine but remain niche due to scale limits. Most modern CSP uses a two-tank molten salt system. The solar field heats hot salt stored in one tank. When electricity is needed, the salt makes steam to spin the turbine, then returns to the cold tank. Storage is durable and cycles daily for years with maintenance. Typical plants carry 6 to 15 hours of storage, enabling true nighttime solar without separate battery systems. PV costs have fallen fast and dominate new solar capacity. Even so, CSP's value is its dispatchable, low-carbon power and its rotating turbines that support grid stability and frequency control. Hybrid projects combine cheap daytime PV with CSP plus storage for evenings and nights. This mix reduces fossil peaker dependence and smooths renewable output over a full 24-hour cycle. A flagship example is the Cerro Dominador power tower in Chile's Atacama Desert. It couples 110 megawatts of CSP with 100 megawatts of PV in one integrated complex. Cerro Dominador uses roughly 10,600 heliostats over about 700 hectares to heat a tower top receiver around 252 meters high, achieving very high temperatures. Crucially, the plant includes about 17.5 hours of molten salt storage. Under the right dispatch conditions, it can deliver solar electricity day and night, demonstrating firm renewable power. Morocco's Noor Ouarzazate complex illustrates scale and diversity. Noor and Noor to our parabolic trough plans with roughly 3 and 7 hours of storage, while Noor 3 is a tower with similar storage. Together they showcase both trough and tower technologies at utility scale, proving standardized thermal storage and offering lessons in financing, operations, and grid integration across a large site. In Dubai, Noor Energy 1 is a 950 megawatt hybrid, a 100 megawatt tower and 600 megawatts of trough CSP, plus 150 megawatts of PV in the same park. The design targets dispatchable output from CSP alongside ultra-low-cost PV, building around-the-clock solar resource tailored for a sunny grid with strong evening demand. Ivanpah in California pioneered large-scale towers in the United States with 392 megawatts and over 173,000 heliostats. It proved complex tower controls at scale. Ivanpah also revealed challenges, including costs, avian impacts from intense solar flux, and competition from cheaper PV. Those lessons have shaped sitting practices and technology improvements. On performance, modern towers commonly exceed 560 degrees Celsius. Higher temperatures improve steam cycle efficiency and make thermal storage even more cost-effective per kilowatt-hour stored. On costs, PV and wind still lead in pure energy price. CSP competes on system value, dispatchability, evening peak coverage, and synchronous machine benefits that inverter-only resources may not fully provide. System planners increasingly look beyond energy-only metrics and consider the whole grid. CSP can reduce curtailment, back up variable renewables, and provide reserves that help maintain reliability. Environmental factors matter. Large mirror fields need contiguous, high-insulation land and careful sitting to avoid habitat disruption. Tower flux can harm birds, so developers use deterrents and operational controls. Water is another constraint in desserts. Dry cooling trims water consumption versus wet-cooled steam cycles at the cost of a small efficiency penalty during the hottest hours. What CSP is especially good at? First, built-in long-duration storage. 6 to 15 hours of molten salt storage is routine, delivering firm, clean power overnight without separate battery farms. Second, synchronous generation. Turbine-based plants provide inertia, voltage support, and spinning reserves valuable services when renewable shares rise and grids need stable dynamics. Third, industrial heat and hybrids. CSP can supply high-temperature process heat, pair with PV for hybrid parks, and even support green hydrogen projects that benefit from steady thermal input. Key challenges include head-to-head cost competition with PV plus batteries. As solar modules and storage get cheaper, CSP must emphasize dispatchable value rather than raw daytime energy. Another challenge is engineering complexity and bankability. Towers, heliostat fields, salts, and high-temperature receivers demand careful design, robust materials, and experienced operations and maintenance. Sitting and transmission also matter. The best direct normal radiance is often far from load centers, so new lines and grid planning are essential to unlock world-class solar resources. Where the field is headed, hybrid power parks that blend cheap PV for daytime with CSP plus storage for nights and peaks. This architecture matches demand profiles while keeping emissions low. Next, higher temperatures and better materials. Advanced salts and receivers aim to push hot tank temperatures up, improving thermal efficiency and cutting costs over plant lifetimes. And finally, a shift from least-cost energy to least-cost systems. When planners price flexibility and reliability, dispatchable renewables like CSP become a powerful complement to PV and wind in sunny regions.